To first run AI, you first need to install Python, which is a very popular AI language to code. And Python have a lot of versions. For example, there's 3.7, 3.8, 3.9, 3.10, etc. And mostly languages like PyTorch, TensorFlow, Transformer, JAX, which is foundation of creating AI models and open sources, is mostly using 3.9 to 3.10 Python version. And me personally prefer 3.10. So let me show you how to install Python 3.10. You just type Python 3.10 download. And you click on the first link. And down here you can see it's this main page for Python. If you have MacBook or Linux, I don't think there's Linux over here, but if you have MacBook or Windows, you can just install the version you have. For me, it's one Windows installer, 64-bit. And after it's installed, you just click on it, it'll open. Click on add Python 3.10 to path. If you don't do it, you need to do it manually. So you can just automatically add to the path. So when you call pipe to install libraries, you can just instantly call it and just click install. So as you can see, I finished the installation and I can just click close and your Python is already done for you. And there's a few open source code edit online right now. So me personally prefer Visual Studio Code. It's a very good tool to use and a good app. You can manage C++, Python, and a lot of other languages beside Python. So right now I'm going to show you how to install Visual Studio Code. So you just go to Visual Studio Code and you just download it. After you finish downloading, you open it and you press agreement and next and next. I prefer to create a desktop icon. You can not do that. Also, it's automatically add to the path, though you don't need to click on it like what just did on Python installation. As you can see right now, when I finished downloading it, you just press finished and you're going to open it automatically. Press Ctrl save to save the file in case you forgot it. I'm just going to save it to desktop. Python py is the ending for the Python file. And over here it's a Python file. So there's a few common used library in Python that is used for AI training. For example, Matplotlib, which is showing how the graph works. Pandas, which is how to import data. NumPy, which is a library that used for arrays, calculation, and scikit-learn. It contains a lot of other chain model that you can call it and you can just run it directly. And Seaborn is also another graph, a library to show different type of graph. And to install them, they're actually not automatically installed in your Python libraries, so you need to install them manually. So in the terminal, you just type pip pipe install matplotlib pandas numpy scikit-learn Seaborn, and that it will install the stuff. And I already installed it before, so I don't need to worry about installing again. For you, we're gonna take like a few minutes. And that's the basic libraries. And there's one main library that's used for AI. It's so basic that it's very common used for mostly every single models. It's called PyTorch. And to install PyTorch, you do pipe install torch, which stands for PyTorch, torch audio, torch vision. And this is only for CPU usage. So if you have GPU, there's a standard type of installation and you can just search it online. As you can see, I installed most of them, so I don't need to wait for it. So that's basically how you install libraries, install Python, and install Visual Studio Code. And you're mostly finished for setting AI related stuff, and you can just directly jump into coding. As I mentioned previously, those libraries is used in AI, and now I'm going to show you how to use them. So first of all, you need to install those Python libraries. Pandas was basically used for data loading and analysis, and Seaborn is advanced statistics plot, and Matplotlib is for general plotting. And first step, if you already have the data right here, I can open it for you. The data is just full of strings of a file that have .csv at the ending, and I have like 500 of them. You can easily find it online in either Kaggle or Google Datasets. And now I'm just gonna import that using pandas, which is shortened to PD. So pd.read_csv. So I'm gonna load the datasets with the data, with calling this file with its file name into pandas data frame, and give it to this variable. And the second line here, we just show how showing how the first 5 of the datasets look like. So you can just do, you can just do print. You just print that because it will not automatically print that. So you need to print it manually and press run. If you run it, ignore the bottom part, ignore that. So you can see right here, it's with how much rows of data you have. So it's 5 cars right now, because computer always starts with 0. So here's the first 5 cars with its name, age, selling price, and field types, and etc. You can just easily see how each data is shown using this data name .head parentheses. The next line is accessing only a certain particular column, which is like the type. For example, it's age. Right here, like I mentioned right here, age. You can just put age in here. Seller type. You can just put the seller type in here in the commas. in the quotes. And when you print it, so as you can see right here, I print out the column of the car data for the field type. And the difference between the top part, this one, and the bottom part with only one square bracket, is just one with the title, which tells the user the column representing their dataset, which is field type right now. And with only one square bracket, it won't show this title right here. I can just show you right now. When I run it, it won't show the title. It's just gonna list the whole number, and so it will be very confusing, because you can see it will be very confusing for debugging because you don't know what it represents. So for the next line, car data, miles, square bracket, what miles driving. Add another column into the data sets, which is equals to kms driving in the column times 0.6214, and just insert it to the data set. As I can just print it right now. You can see right here, it added one more extra column, miles driving, and before it doesn't have one because it just added to the variable, but it didn't change in the files of your data sets. It just changed the column. It just added a new column to the variable with car data. And the next line is basic. It's very easy because it just get the length, and if you print it, it will just basically tell you how much car in your data is existed. And right here I have 301 of the data in my datasets, which actually matches. Right here, 303, 302, and minus 1, which is the title, is 301 datasets. Data in the datasets. The next line is actually very useful. So let me give you a sample. In the fuel type right here, there's Puro and Pedro for different types of cars, and it is going to repeat over and over time. So here it just group all the possible repeating to 1. So meaning it was gonna output 2 because there's only 2 type, or maybe 3. So let's see, because Pedro and I didn't print it. Because Pedro and Diesel is 2 type, so it should be printing 2. Yep, there's 2, and it also lists how much it repeated. So there's a diesel. There's 60 cars that use diesel fuel type, and 239 for Pedro fuel type. And the next we go into scatter plot, which is using Seaborn advanced version of Matplotlib library from Python. Basically, you give the variable that you want to plot. For example, in here we got age for x-axis and y-axis for selling type. The S actually mean how big your dot wanted to be. It just generally show how general trend or relationship between for example in here, age and selling price. As you can see, in age 2, that car have used 2 years. A various range of from $40,000 to $0 of car selling price, and until to age of 16. You just compare the relationship between the age and selling price. And for the next is cat plot, which is used for visualizing the distribution of prices of each in this case is fuel type and selling price. This kind is actually there's various type of kind. Is how you visually show the plot. So in this case, swamp will just be spreading all over. It's spreading all over. And for each one, just compare how much petrol type of car, petrol fuel type of car have sell for. For example, in here is around $28,000, and there's only one type of car, which is CNG. I don't know what that is, but it's probably the one of the fuel type. The next one is box plot. It just compare the price distribution across and type right here, and it have the mean and the outliers over here, the outliers and the mean of the whole dealer and the individual seller type of each car. It just compares. Next one is his plot. KDE right here just add a smooth density of curve for better understanding. So I'm just gonna show it for you guys. Yeah, it's just trend how much cars that cost that much of money. For example, is from 0 to whatever number that is. There's 100 cars, and there's a trend over here shown by the line that it is decreasing the selling price as the age pass. And pair plot, it's just showing a lot of plots and letting you to compare this line right here, this 9 right here, and this different type of comparison. For example, is age to age, age to selling price, and various difference of plots that you can compare with. Last but not least, it's line plot. It's also a plot that's showing the trend of the variables, and it's just using x and y. As you can see, it's just line. It's just showing how the age is passing and the sample is decreasing. And there's a bump right here, you can see it. It's using the data to plot it. And the last is plot.show. It basically just show all the plot that you define on top. For example, I define line plot, it just show it. If I have multiple plot that is defined, it will show it multiple times. Thank you for listening. Hope you subscribe to Using STEM. This is my first video, and the next video I'm going to introduce linear regression. Hope you guys is looking forward. Bye.